Let's start this session within a 2 minutes of time.
Good evening, guys. This is Aditya V. Today is day 3 of this 5-day summer workshop, Step into Robotics, Basics and Beyond. Today, we'll be seeing about uh, some small circuits with couple of new components than you saw yesterday, and then we'll be showing you a project demo of one of the projects we had already done. So let me share my screen 1 second. Okay. So first, we'll be starting with an LCD display. Do any of you guys have what an LCD display is related to small electronics and robotic stuff? You can use the chat box to answer. Yeah, that's correct. Like a display, digital display. It's an electronic component that can display what you want to show. So here I'll be opening my TinkerCAD. Here I'll be taking an LCD display. So here you'll be seeing two kinds of LCD display, LCD 16:2 and I2C. I'll be explaining it in a while. First, let's take the normal LCD display. So an LCD display is a display, and it has 16 pins. So each pin have their own purpose. So the first two here are LED pins. So this LED is basically just the backlight. uh, yeah, it's a backlight so that you can see what goes on the LCD. So the anode, you will be connecting with the positive side of a battery, and cathode to the negative side, like or ground. So here you will be seeing D0 up to 7. So these are digital pins. So an LCD display of this type converses or communicates with the Arduino in a parallel manner. So I'm I'm sure juniors wouldn't understand this, but second years will. So there are multiple kind of communication. So I won't go into that. This is 8-bit communication. Then there is the E, which is enable pin. Enable pin helps you to enable it. So think of it similar to having a TV. In a TV, you're connected to the plug point and you're switched it on, but the TV won't on because you need to switch it on with the remote. So that's what this enable does. Even once you give power to the VCC and ground, this will be on, but the data or anything will not be traveling. To make sure that data will be traveling, this enable makes helps us decide when the data will be sharing or not. Then is read slash write. So this has two states, 0 or 1. Like all these pins can either take 0 or 1 as their states. So in this read or write, it will say what we are going to be doing to the LCD sensor. Either we'll be reading from the LED sensor LCD or writing on the LCD. Here, if you give 0 as an input, it will write, and when you give 1, it will read. But since reading from LCD is mostly not required, we usually ground this pin. RS is register select. So register select, as I said, in an LCD there are multiple things you can do. Of course, the major thing is publishing things like displaying the data. But what you can also do is give it some commands. For example, here in the LCD display is a 16:2. What that means is it has 2 rows and 16 columns, aka 16 characters. So let's just say you have typed my name Adi and you need a space. What you can do is instead of giving a space, or you need to go to the second line after that, you can't just give enter. You need to give what to do. So what you do is there is set cursor. There's a function called set cursor, which will move the cursor to the next line or where you want it. So that's the use of register select. Whether we will be giving commands that move the cursor, clear the LCD, or we will be sending the data to be displayed on the LCD. Next is the V naught, aka contrast selection pin. So a contrast selection is simple. Uh, you would have seen the new. Everyone would have used our calculators right now, right? We'll be using the scientific calculators. The scientific calculators, if you have gone to the mode and check for display, there will be like arrow for two sides. What it does is, it makes sure you can see. Okay, sorry. What the contrast does is make sure that in different kind of environments you can see it clearly, because sometimes when it's too sunny you need higher contrast so that it will be visible to you, but at night times you won't be needing that much contrast. So to select how much contrast is needed, this V naught is used. Usually we connect this V naught to a potentiometer, as Karthikeyan would have told about yesterday. When we connect to the power source and ground to the potentiometer and take the wire from the middle part, we can get a variable voltage between the two, the ground and the VCC we have provided to the potentiometer. So that's what we use here. We'll be connecting the third middle pin of the potentiometer to the V naught so that we can control the right contrast of the display. And then VCC and ground, which are usual, they are VCC and ground to power the whole thing. If you guys have any doubt, please feel free to ask, or anything I need to explain again. I'll wait for 2 minutes. Come on, don't you have any doubts? Plus one. What's plus one? Chandra bro? Oh, I meant okay. Okay then. Does anyone have any doubts? If you have any, please contact. I'll go to the next one then. It seems like you're not clear with this one. So the next kind of LCD display is the I2C. If you are wondering what an I2C is called an inter-integrated circuit. Sorry, communication. So what it is a way of communication with the microcontroller directly. So like think, which is this is similar to how, take a mouse. You'll be having a USB-C there, USB-A cable to connect it to the laptop. So what it does is it communicates the movement of the mouse from the taken from the sensor and translates it so that you know that the cursor should be moved in this way or that way. So that is one type of communication. So these generally use serial communication. There are two types of communication: serial and parallel. So this one is a serial communication. It connects directly with an Uno R3. So let me just take an Arduino for 1 second. These are SDA. We can see SDA and SCL. So what these are is that SCL is the clock and SDA is the data. So SDA will be transmitting data between the two sides. It will be coming from nano to LCD and LCD to Uno. Sorry, I'm used to working with nano, so I'm confusing it with. So this communication is seamless. The clock is here to make sure that the communication happens properly and on time. To make sure that like when transfer is happening from Uno to LCD, it doesn't interfere with the other way. So you might be, maybe you will be asking, you may will have doubt that, okay, these are only 4 pins. Like, why did we so far see with one with 16 pins? Why did we need that? You'll be asking. So there is a reason for that. The main reason is that the speed of it. So in case you have a very fast application, so you need the photos and like the what your character should be changing at very fast rate. The serial communication is a bit slow compared to the parallel communication. That's one of the major reasons. And the thing is, SDA and SCL are not available on every microcontroller, but other digital pins are available in every microcontroller out there. So that one is more versatile, but this one is more easy and what to say, convenient. So if guys any have any doubts regarding the I2C communication or anything, please put in a message. I'll try to explain it again. Don't worry about chatting. It's okay. You can say anything. How do we connect both of those pins? What are we giving to SCL pin? So we won't be like how we'll be connecting this. This SCL pin will be connected directly to the SCL of the Arduino Uno, and SDA will be connected to the SDA of the Arduino Uno. So they communicate within each other. The inside of those, like inside content, is not too important for us right now because we are taking basics. So Balaji, we won't be giving anything. The Arduino will be speaking with itself, so that there will be an internal clock with an like there is a LC oscillator in there, sorry, crystal oscillator in there. So that internal clock should be matched so that
Guys, can you wait for 1 second? There's a small technical glitch. There's a small connection. That you can wait for a second for a while. Do you guys have any other queries? Do post in the chat box. Yeah, Janani, do post in the chat box.
I'm extremely sorry, guys. I got into an internet issue. I'm extremely sorry. I will be continuing now. Chandru, like, please elaborate on your question. Like, I only got half of your question. To time data transfer correctly from what I wanted. Okay, you've been speaking. Okay. So, I had. Do anyone of you have any other questions? I need to rectify. If not, then I'll continue. Okay, then I'll go to the next. So the first circuit we'll be seeing is with an ultrasonic and an LCD display connectivity. So in this circuit, what I have just simple circuit. So what we have done here is we have connected the LED cathode, which is this one is a cathode. So we have connected it directly to ground, and then we have connected the positive end anode to the VCC. But you would have noticed there's a resistor here. So what's the thing here is if we do not have a resistor in an LED in this in the TinkerCAD and sometimes in real life, the LED does not take 5 voltage current. When you think it's 5 voltage, but the current will be much higher. When the current is very high, the LED will just burst. So the same thing happens in TinkerCAD too. So we gotta use a small resistance to make sure that the backlight doesn't explode. So I'll show you an example here what happens. So here I'm not connecting the LCD right now, take the resistor right now, and I'll be connecting it to the, the 5 volt. Then if I start simulation, it just blast. So LED is used so that the current doesn't go too much, so that the like current doesn't go too much, and issue like this happens. So then we here, as I said, smart connectivity. So we have connected 4 pins. We can either connect 8 pins for, since we will not be sending too much data here, I have connected only 4. So these 4 pins are connected directly to 4567. So 4567 is connected to 4567 in the Arduino Uno. Next, we are not using this, and the enable is connected to pin number 10 in the Arduino Uno. After that, as I said, read write. Since we are only writing, we can directly ground the read/write pin, and then the register select we have is connected to the pin number 9. After that, this V0 is connected to the potentiometer. So in the potentiometer one side is connected to the VCC, which is 5 volt, and then the other side is connected to the ground, and the middle pin is connected directly to the V0. Then VCC and ground here is everything is 5 volt. So everything we used here is 5 volt. Since all these things are 5 volt. So here I have also connected the HC SR04 ultrasonic sensor, which is the normal VCC and ground. The trigger is connected to the pin number 2, and the echo is connected to pin number 3. So yesterday would have learned the thing about ultrasonic sensor. So let's jump into the code of this circuit. So in this circuit, since we are using the LCD display, as we saw, there are so many pins for us to say it to do everything. We won't be knowing everything to do, because register start, register select, object to a class. So liquid crystal is a class that we're more or less importing it include, and we are creating an object LCD1 that will be controlling this LCD. So after this, I created a small function to just get the value from the ultrasonic sensor directly instead of doing it again and again. I made a function here instead of, like, for simplicity. So in the void setup, we use LCD1.begin. Begin, what it does is it sets up the LCD display so that it can start to display. So once you give begin, the LED will be like backlight will be on, and the whole thing will be empty, and the cursor will be set at the start of the thing, which will be 0, 0. So just like in every computer science array and everything here also starts from 0. So this is to calculate the distance from the time. Yeah. And LCD print, we are given 500 millisecond delay for simplicity, and LCD1 dot clear to clear the LCD. This is a very simple circuit we have done here. I'll be showing the simulation now. So here I have selected it, and now as you can see, it shares 123 centimeter here, and it's 123 centimeter here. So, as soon as I change it, it will be changing. So that 500 is what, that every 500 milliseconds it is changing. If I change that 500 milliseconds to say 1 second, every 1 second it will check the value. So it's more or less like sampling rate. Sampling rate, sampling rate is in how much time do you check it. So so far this is one circuit. Like everyone understood what it is. Anyone have any other doubts? Got it. Okay. Anyone else? I see only couple of people are commenting. If others, if you got it, say got it. It's good. I'll know that. Okay, people have got it. எனக்கு நடத்த தெரியும். Yeah. Okay. Then next we'll be seeing one small thing. Anyone know what is a motor driver? Okay, I'll be here. Let's not give it away. Have any idea what is a motor driver? Anyone? No. Okay, in simple, motor driver is like a mediator. Think about it. So here, let's just say you have a motor. It's a 12-volt motor. It can only rotate from the values between 0 to 12. But an Arduino Uno can only supply voltage from 0 to 5 volts. So we need to move a motor with this 0 to 5 volts. To do this, we are having a no money gun. It does not give initial power to start. Like I'll be explaining it to you. So it moves from 0 to 12, right? Controls the power of the motor, more or less. So as I was saying, it moves from 0 to 12. But Uno can only provide 0 to 5. We need a mediator so that it can scale that 0 to 5 to 0 to 12. That is a motor driver. So also what we can say, a simple analogy is that you would have known about the levers. You have studied in the school time, simple systems and complex systems, I think. In that, let's just say that's a big, yeah, amplifier of sort, exactly. So in that there will be a big, think about it, there's a big rock. You can't move it with the bare hands. But so what you can do is you can lodge a stick into it, and if you pull the end of the stick with minimal effort, you can move it. So think about it similar to this. That's what a motor driver is. It helps us drive a motor with the help of a small circuit, some small current. So what we'll be talking about today is L293 motor driver. So an L293 motor driver is a very widely used motor driver because of its simplicity and low cost. This in usually in ICs, you will be always seeing this one small dot and the divot. So whenever you see IC, the one below this whole small dot will always be the pin number one. It will go from 1, 2, 3, 4, 5, 6, 7, 8. Then it will switch here 9, 10, 11, 12, 13, 14, 15, and 16. So in this IC, has the first pin is an enable pin. Enable, as I said previously in the LCD part, it enables you to control that. Can also enables you to do the thing. You'll be giving VCC, you'll be giving, but you don't motor driver won't do anything. Why? You haven't given an enable. So in a motor driver, enable has another use, secondary use. The secondary use is that it is the one that scales the values. So if you're giving 0 to 5, it will 0 to 5. It's the thing that scales it from 0 to 12. So the second one is input 1. So input 1 will make sure the motor rotates anti-clockwise. If you give pin 1 high, it's a digital pin. It takes only 0 or 1. So when you give this here, it rotates anti-clockwise. And the third is output 1. So you'll be connecting output 1 to the motor directly. And there are 4 grounds here. I'll be explaining why in a bit later. The pin number 6 is output 2, so you'll be connecting to the other end of the motor. So other in the sense, one will be positive, this one will be negative. And then this is input number 2, which when given high, it will rotate in clockwise motion. Pin number 8 is the positive for the motor. So you need to drive the motor at 12 volts, means you have to be giving 12 volts to this. And then the pin number 9 is again enable 2. Here L293 has motor drivers in a single IC. So left side is one motor driver, right side is one motor driver. So the second set of pins, so from pin number 9 to 15, do the exact same thing as what I said just now. Only difference being the 16 pin is the connection for the IC itself. So for every IC, it requires a VCC of 5 volts. So every IC needs for the internal electric requirements. So this is used for that. So simply, we'll be thinking, how does it work? How does when I change the input from one to the other, it rotates in anti-clockwise. So for that, we are using a circuit called H bridge circuit. So as you can see here, this one looks like an H. That's why it's called H bridge. So when you give input as 1, right? Okay. When you give input as 1, what happens is there are 4 switches here. So when you give input 1, it goes S1 is on and S4 is on, which makes a flow from the positive to negative of the motor, and the other 2 switches are off. When you give input 2, what happens is these 2 switches get opened and the S3 and 2 get closed. Now it has the current travels from the negative to the positive of the motor, making the motor rotate in the opposite direction. So this is the simple thing about this circuit. Okay, anyone have doubts? Like full wave bridge rectifier does. Yeah, exactly. Exactly, that's what it does. Okay, if you guys have any doubts so far, please inform me. Then I will be going to the circuit and we will be moving on.
Feel free to ask the doubts, guys.
Okay, one H bridge. Okay, I'll be explaining the H bridge again. Okay, a H bridge simply has 4 switches, more or less. So if you see here, there is switch 1, 2, 3, 4. So when we give input 1 and 2, it has internal circuitry such that when we give input to input 1, the switch number 1 and 4 get on and the switch number 3 and 2 get off, so that there will be a flow of current through S1, then S4, then to ground. So that in the circuit, what happens is the current travels from the positive end to the negative end of the motor. So this makes the motor rotate in a clockwise direction. Once we give input to the input 2, what happens is now the S2 and 3 get on and S3 1 and 4 get off, making the circuit reverse and make. Now as you can see, this one is short, this one is short, so that the current is flowing in another direction from the negative to the positive of the motor, making the motor rotate in the opposite way. So this is the simple HV circuit. This is not the actual exact circuit there, but it's a representation of it. Hope you guys understand. Like, how do we control the H bridge? We don't control the H bridge, like we won't be controlling it. The L293D IC has a lot of internal circuitry. So I'm just saying how in general, just a representation of how it works is that one circuit. Internal circuitry is very deep and it's a very vast concept. So that one will not, already I'm taking time. So that's the thing. You guys any doubt? Did you guys understand H-bridge? Where do we use H-bridge? As I said here, use H-bridge in the L293 DIC and in various applications where reverse of the current is required at certain times. Like in this motor driver, one set of times we will be needing, when one input is on, we'll be needing a circuit in one direction, and when the other is required, we need to change it. So when the application arises that this direction of current needs to be changed consistently, we use a H bridge there. Got it. Okay. Okay, then I'll go to the circuit design now. So here I have a simple L293 connection with then now we have used the LCD, SDA and SCL I2C connectivity LCD display here. I'll be telling you what happens here first. So this is a motor. In this specific circuit, since we are using in TinkerCAD, we have only 5-volt motor, so we'll be using 5-volt everywhere. But in real life circumstances, the 5-volt the motor values will be changing. So let's start with the L298. So first, enable 1. So enable 1 controls the input of the first motor. So second motor is not here right now. We'll be using only the first motor for now. So enable 1 I have connected to pin number 3. So pin number 3 is a PWM pin. In case you guys, I hope you know what PWM is. In case you don't know, I'll explain it in a short way too. A PWM value is a value between 0 and 255 specifically in Arduino. So what it does is it is similar to analog value where it gives a continuous set of values. So here, as I said, we need to be scaling it from 0 to 12. So to make sure that in here we can use in the code, we can use from 0 to 255. So what PWM is that, think of it as, let's just say you have a water bottle and you're filling it with water, but the water bottle also has a hole which is consistently leaving out the water. So to maintain one level of water, you need to be controlling the flow of water. So once you increase the amount of water falling into it, it will change the level at it will stays. So that's the basic concept of PWM. Similar to that, I'm not going too deep into it. So in an Arduino Uno, every pin that has a tilde symbol on it is a PWM pin. So enable, since we will be controlling the speed of the motor here, I've connected it to enable to a number. So then I have connected input 1 to pin number 4 and output 1 to the motor, output 3 to the motor, then the input 2 to pin number 2, the VCC of the motor to 5-volt here. As I said, in TinkerCAD there is only 5-volt motors available. We couldn't get anything. And also the 5-volt for IC here. We are not using any of these pins. So here for the LCD display, we connected SDA, SCL directly to the SDA and SCL of the Arduino Uno. So also I forgot to say about it. The L293 motor driver cycle has 4 grounds instead of usual 1 or 2. The main reason is that since we are dealing with high voltages of high voltage values, like sometimes you can the thing is it can even uh, handle voltages up to 40 volts. So when that happens, the IC may get heated too much and the current should be grounded properly. To make sure that grounding happens properly, there are multiple grounds here, and heat sink also be connected to the grounds. That's the main reason for it. Now let's jump into the code of this one. So as I said, this is a bit different LCD display. So we'll be having a different different Arduino function called Adafruit Liquid Crystal. So it's exact same thing to that, but instead of giving any values that we can just directly pin values, we can just directly give LCD underscore 1 0. In the setup I have given begin and I have set pin mode 2 3 4 to be output, so that we'll be getting the output properly. And just set backlight is a function in SD and SCL, like sorry, in Adafruit Liquid Crystal library that make sure that the backlight is on. So instead of that, where everything is controllable specifically, these just two pins, SD and SL, connect everything together themselves. Yeah, in the loop, I have just written what is. So I have first given digital 3 as high. Digital 3, what it is? What is digital 3 is? A or enable. So once it is given high, the motor will rotate at a maximum speed. And then I have printed clockwise on the LCD display. Then digital right, I have given input number 4, input like pin 4, aka input 1 as high and input 2 as low for clockwise rotation. And then we are clearing the we are waiting for 3 seconds, clearing the LCD, then we are setting the cursor to 0, 1 so that it's in the next line, and we are now printing anti-clockwise. Then we are writing now we are inverting it so that it will be rotating in the other way around. Then we are clearing it again. So now let's just see what happens. Like, let's just see what happens now. RPM in the opposite direction. So now I'll ask, like, what happens if I just give enable as 0? Shall we see? Like, so. And also one thing about Arduino is that you can use high or 1, 0 or low. Both are interchangeable. These two can be used simultaneously. So here I have given this enable as low. Like now, as you can see, I have, like, there's nothing, motor is not rotating because the enable has been set to low. There is no voltage available. So then we can also use analog write to control the, oh sorry, we can also use analog write to control the speed of the motor. So I'm giving 3. So let's just give, as I said, we can give values from 0 to 255. Let's just say now I give 50. When I run this now, the RPM will be reduced from the 9000 to some scale value. See, the RPM is now 1800 to 1700. Now, if I change the 50 to say 200, now you can see the motor is rotating at around 7000 RPM. So this is how you control a motor with an L293D motor driver. Hope you guys understood this. If you guys have any doubts, just feel free to comment and ask it. Bharat Vishnu, there are multiple motor drivers already connected. Like there are you there is one module called HW10 L298D. So there are multiple motor drivers already available, which already have the circuit integrated on them and soldered and everything. So you can use directly. But for sometimes for very specific use, Harish, it won't work. It takes only 0 or 1. When it goes over 1, mostly it takes as 1 because it takes the higher value. Okay, so I think everyone understood about this, everything. Is it binary? Yeah, it is binary. Yeah, 0 and low are same, 1 and high are same. We can use them both interchangeably. Okay, so that's it for this session. Next, Srivatsan will be starting. Before that, I'll be telling you what a manipulator is. I'm guessing day before yesterday, first day, you have give attention, you would have learned what is a manipulator, basics of robotics. A manipulator is a device that is used to manipulate materials without direct physical contact by the operator. So more or less, it's a robotic hand which manipulates its surroundings for you without your intervention by itself. Okay, by itself. This is mostly used in bio, like most used for manipulators is when there are very repetitive tasks. So think about it. In example, I think some people might have seen in the movie Charlie in the Chocolate Factory, the father gets kicked out of the company because his work is closing the like, toothpaste caps, but he'll be replaced with a manipulator. So because it's a very repetitive task, it's a precise task. It's better to have robots there. So even it's manipulators are used in various different industries for precise control. So if you guys have any small doubts related to manipulators, you can ask me. More or less, yeah, because manipulators are robotic arms. No, any remote controllable device will not become a manipulator because let's just say a controllable device, a car, let's just say a remote control car, it just drives around. It won't be manipulating anything. This manipulator will be able to control. It will be able to move in a three-dimensional direction and be able to do some work. For example, there are multiple kinds of end effectors it has. End effector in the sense the hand, more or less your hand. If it's just a hand-like thing, it can be able to pick and place. Manipulators are in its yes, manipulator does have a microcontroller of its own. Mostly they use Raspberry Pi. So Harish K, why are manipulators inaccessible? In the sense, you're asking why it's always covered in Harish. How many axes?
It's just have 60 degrees of freedom. You can understand that.
Yeah.
Yeah. I will explain
Yes.
the entire part. You can go. Adi, you can go
Yeah.
through.
Now I'll give it to Stevenson and he'll be speaking about next. Yeah. Thank you guys. I'll be coming back.
Yeah, hi guys. Once again, welcome to the workshop conducted by the RCS. This is me, Stevenson. Uh, Once again, welcome to us. Hope you all have enjoyed the day one and day two of our workshop, and also the earlier today conducted by the Adi. Now, let me explain. You have learned what is a manipulator, but who doesn't know how does a manipulator work, right? Okay. Now, let me explain that how does a manipulator work once again. Hope everyone is able to see my screen, right? Okay. Once again. Okay. Now you have learned about what is a manipulator in day three, before, as Adi have explained, and day one about that. But you have a doubt that how does a manipulator work, right? Yeah. Now let me explain. Before going to the working of a manipulator, just see your hand, right? The shoulder and the forearm are connected to the elbow, right? Uh, these two have connected with for the movement of that, right? For that, the forearm and the elbow, the shoulders are the links of the your hand, and joint the elbow which is connected the forearm and the shoulder is the joint of the joint of your hand, so that the manipulator composed of links and joints. So, like the same way you can compare and contrast how does a manipulator and a human arm works. It's work like that. And then you have a doubt what is end effector, right? As Adi have explained earlier, it's like a hand thing, right? End effector can be various things, like spray paint. It can be the manipulator can be used in painting industry to paint the object. Spray paint can be end effector, gripper, and lots of things. Depending upon the application, the manipulator, the end effector of a manipulator can be varying, right? Right. I think you have all get it right. If you have any queries, do post it. Okay, right. Let me move on to next one. Okay, right. Let me move on to this one. Now we have seen that how does a manipulator works, right? Now let me explain the types of manipulator: Cartesian, cylindrical, polar, joint arm, and SCARA. SCARA is the one of the most used in the industrial robotics, especially in food tech industries, to pick the packed parcel from a place A to place B by placing it right. And then joint arm is also used, which we are going to see as a DIY project later in this session. Before that, these are the five types of manipulator. And then you have asked how many axis of rotation does a manipulator have, right? There is three types, three rotational axis. One, so you can see that. Let me full screen it down. No, you can see one, two, three axis of rotation, and then you can move in x, y, z, and theta x, theta y, and theta z direction, right? This is a maximum 6 degree of manipulator, which is more and mostly used in the higher level industries. Okay. Do you have any queries? Do post it. Okay, right. Okay. Then application, where do we see the application of manipulator is mainly used in food industry, as I have said earlier, and also used in painting of a part, specific part, which can be if we need a paint in certain parts, we cannot go inside and paint the entire part, right? For that complexities, we can use the manipulators for that thing. And then the manipulator are also mainly used in cargo cargo industry, to pick up object in place A and travel to a path and place the object in place B, right? It is the one of the most used most used in cargo industry. And also there is a research going on in ISRO and NASA. If you take samples from the manipulators, are all
Stevenson,
collect the sample. Hope you all have understand. And
Watson,
also how
hey
now.
Watson.
Feel free to ask. Yeah.
Voice it's breaking a bit. Like check your internet
Once
once.
1 second. Let me check now. Now can you hear me clearly?
Yeah, I can. Yeah, continue.
Okay. Now is it okay for everyone? Okay, right. Let me explain again the thing. Right. Let me explain again the application of manipulator. Manipulators are used in various industries like uh, cargo industries, food industries. Industries, especially it is used for packed item to be picked pick the packed item
Watson, it's breaking. It's breaking. Voice is breaking. Watson, voice is breaking.
from the
Hey
produced
Watson,
thing from the belt and
Watson,
place it in the box used for the. Again, once again.
Watson.
One
I voice is breaking.
one second.
Voice is breaking. Okay, okay.
Now can you hear clearly? Okay. It's okay for others. Okay. And the manipulator come robot a rover from to collect the samples from the various places of the planet and take to the place take to the research. Rover is used to collect the samples and the rover is used to able to see the working of the manipulator. Okay, any queries? Do post in the comment box. Let me wait for 2 minutes. Have you all guys have clear idea about what is a manipulator, how does a manipulator works, and where do we need a manipulator, and what are the future projects of the manipulator? Right, right, okay, right, okay. Now, okay, right. Now let us jump into the 3D model of the manipulator. This is our sorry for the inconvenience. There is some
Sense breaking. We can't hear you properly.
model so that this is the 3D model of parts of the manipulator. This is green. Okay,
Yeah, we can see your
one second,
screen,
Ram.
but your voice is breaking sometimes. The screen is clear.
Okay, right. Okay, okay. Let me change 1 second. 1 second, Ram. One second, guys.
Okay, while he's sorting out the issue, I'll tell you what it is. So manipulator generally, depending on the application, it has a fixed base and a moving base. So let's just say you want a manipulator to be fixed there. Think about a car manufacturing plant. So you have seen how it was made back in the days. As a, like you would have seen the show how it is made. In that, there will be a conveyor belt with cars which will be moving, and the manipulator will be placed there, and it will be doing its job more or less. A pick apart and place it there. So that's a fixed base manipulator. But sometimes we may need a moving base where, one second, Mohan, I'll finish this and I'll come to you. Whereas, let's just say you want a moving manipulator. Think about, as he just said, a rover in a Mars. So you need this to move. Watch this or its function. I'll come to it first. 1 second. When you move the manipulator, sorry, in Mars, you should be able to collect samples and also be traversing the whole Mars surface. So for that, we need both movement of the manipulator, so that what we do is mount the manipulator on a differential drive car, so more or less a car, so that it can go around, collect samples, research if it needed. So for your question, Gayatri, do multiplators require an operator who watches over its function? Depends. So most manipulators, once you have coded in that this is what it's gonna do, it won't be needed an operator. But sometimes it's
Yeah,
better to check in case of like a small errors here and there. It may happen. Most manipulators do, Yashwant. Most manipulators are fixed and for one work at a time. The most, not mostly, that's the thing. There are very few which are used for multiple. So the manipulator is the same. What we can do is the code will be changed. If you let's just say, as I said, an example, toothpaste one. So you can use the same manipulator. You can just change the end effector to another and use it for some other application. Okay, I guess your questions are
okay.
queries are solved. Sridhar will take over now.
Sorry guys, there's some internet issues. Sorry for the delay. Uh, Once again, now everyone can hear me clear, right?
Yes, sir.
Yes, sir, we can.
Okay, right. Now can I start? This screen is visible, Adi.
Yes, sir, it's clear. It's clear and visible.
Okay, voice.
The voice is also clear. Okay.
Okay, right. Hope you have lot and lots of applications and thing stuff about the manipulator, right? Now let us jump into the circuit diagram of the manipulator, which we have made as a DIY project of this workshop, right? First thing, we have a Arduino Uno and two motors and a L293D driver, a controller. This set, the complete set is a controller, and three servo motors for the control of the uh, manipulator. Before that, I'm going to explain the 3D model of the manipulator, right? Okay, right. In this in this one, this part is the chassis, upper chassis of the manipulator, and down is the lower chassis of the manipulator. It is connected with the two wheels of the manipulator. These two wheels are connected with two DC motors, and as I have said already, there's some glitch in this this 3D model. There will be a motor present here for the movement of the cutting rod, and there will be a motor present in between the cutting rod and the gripper for the movement of the gripper, and also there will be a motor which is connected in the gripper for the open and close movement of the gripper. Hope all you have understand that. Let me give the 3D view of 360-degree view of the manipulator. And there will be a caster wheel at the down for the movement. Okay, right? Is it clear? Is there any queries in the 3D printed model? Sorry, 3D model. Okay, right? Okay, right. Okay, now let me explain the as you have seen the 3D printed model. With that, let me explain the circuit diagram of the manipulator. Right. First of all, we have Arduino, two motors, as I have said already, a controller, three servo motors, and 9-volt power supply. Right. Before jumping into it, uh, first of all, we are giving the power supply to the Arduino to the pin of V in pin, and then this is a direct power supply to the Arduino, right? After that, let me explain the circuits of the L293 driver circuit. Before going to see this circuit, as Adi have explained already about the driver and how does the pinout diagram, let me recall the what are the pins are in the driver, right? Hmm. This is the L293D driver. The pin 1 and pin 9 are the enable pins 1, 2, 3, 4 respectively. And pin 2 and pin 3 are the input pin 1 and output pin 1 respectively. Pin 4, pin 5, 12 and 13 are the ground pins. Okay, it is used for the heat sink purpose and avoids a short circuit, right? And then output 2 and input 2 are the pins in pin 6 and 7 respectively, and the power supply of the motor is given power supply for the motor is given through the pin 8, and the power supply of the VCC is given through power supply of the IC is given through the pin 16, right? Hope you all have a clear idea of it, right? After that, for here input 1 output 1, input 2 output 2 is to control motor A, output 4 output input 4, output 3 input 3 is used to control motor B, right? Hope you have a clear understanding of the pinout diagram of the L293 driver. Do you have any queries? Just to post it now. Any queries? Two questions for the queries. Okay, I think there is no queries. Okay, let me jump ground. Karthi, can you explain elaborately what is the doubt?
Karthik is replying to Harish.
Okay, right. Okay, right. Okay, right. Okay, not a problem. Okay, now let me explain the remaining part. Now you have a clear understanding of the driver, right? Okay, now let us jump into the circuit diagram. Here, once again. Okay, hope my voice is clear. Now let us start with the pins. Um, Here we have connected the 9-volt power supply to the pin 9 and the pin 16 for the power supply for the IC and the motor, right? And then the power supply for the, and then the input pin is connected to the uh, now you may have a doubt for what is the use of input pin and what is the use of output pin, right? The input pin is used to convey a signal from the Arduino Uno to the driver, and then the output pin is used to convey a signal from the IC to the motor. Okay, now you will have a clear idea what is the use of input pin and output pin. Okay, if for that the input pin 1 is connected with the 10 pin number 10, and the input pin 2 is connected with the pin number 11, and 3 and 4 especially in 12 and 13. Okay, as you have seen in the, once again, as you have seen the circuit diagram. Ah, the motors, the motors are the movement wheels of the manipulator, right? These DC motors are used for the movements of the manipulator. As I have shown the 3D model, you can able to see two wheels, right? These two wheels are connected with the DC motor of the manipulator. Okay, so that it is used for the movement of the entire rover, which is connected with the manipulator, right? Hope you have understand it. Okay, right. Now, as I have the input pins have been connected to the Arduino. The output pins, there are two poles in the motor, right? If we give positive in one pole and negative in another pole, the motor rotates in clockwise. If we reverse the current of the poles, then the motor rotates in anti-clockwise, right? Same thing. The two poles are connected in the output one. The two poles of the motor A is connected to the output one and output two respectively, and the remaining two poles of the motor, the two poles of the another
Watson, your
motor
voice
is
is
connected.
breaking. Watson, your voice is breaking.
Now, 1 second. Now, can you hear clearly?
Yeah, now it's clear.
Okay, right. And then remaining two poles of the motor. The remaining two poles of the motor is connected in the output 3 and output 4 of the motor to for the clockwise and anti-clockwise of the direction. Okay. Hope you all clear in with the IC pinot diagram of the manipulator, right? Do you have any queries? Do post it. Okay, right. Okay, right. Let me continue with the circuit diagram. Okay, now we have seen the power supply of the Arduino, and then the DC motor circuit diagram, which is used for the movement of the rover. Right now, let us see the circuit diagram of the servo. In we are using the Hutch 90 servo, which is Hutch C90 servo, which is able to get only 5 volts power supply, so that the we are supplying 9-volt power supply to Arduino, right? And then the Arduino converts that 9-volt to 5-volt and give the supplies to the power supplies to the three servos, which we are using in the manipulator. Now you will have a doubt that there are three servos. What are the use of these three servos, right? This servo is used for the used as a base motor, which is used to move the connecting rod of the manipulator, and then this is the intermediate servo motor, which is used to move the offset movement of the gripper, and then this third motor is used for the open close movement of the gripper, right? Hope you all have a clear understanding of these three motors. Now let me explain with the 3D CAD model. The first motor, which is from the left of the circuit diagram, here you will be presented with that first motor, which is used for the movement of this connecting rod, and then the second motor, which is connected in between the connecting rod and the gripper setup, which is used to move, which is used for the offset movement of the gripper, right? Hope you all have understand. And the third motor which is presented here is for the opening and closing of the gripper. The gripper is connected with the gear assembly for the opening and closing. If the gear rotates in clockwise, then the gear sets to be open. If the gear rotates in anti-clockwise, then the gear sets to be closed. Hope you all have understand the motor setup. If you have any queries, do post in the chat box. Okay, right, okay, right. Now let me explain the remaining part of the code. This is the main part. This is the controller of the entire manipulator. This controller is used to control the entire manipulator. Here you will have four switches, switch 1, 2, 3, 4, which is used to for the forward, backward, left and right movement of the manipulator, right? Hope you all understand. This is only for the movement of the rover, either in forward direction or backward, left or right, okay? And then you will have a doubt that why there is a LED connected to this controller, right? It is just an indication of the controller, whether there is a connection, whether if the LED blows, then we will assume that there is a connection in the controller. If LED doesn't blow, even though there is a power supply, then let us assume that there is no power supply to the controller. It is just the indication for the connection purpose, right? This first pin, the pin which I am showing is for the forward movement. The pin which I am showing now is for the backward, right and left, okay? Hope you all have understand. In this, these four pins are connected to the Arduino in the pins 0 to 3 for the movements. For these things can be we can explain elaborately in code, right? Hope you all have understand. Do you have any queries? Okay, the LED is for the indication. It's not nothing. If we doesn't use, if we're not having a LED, there's not a problem, right? It's just as I said already, it is just a indication purpose. It just to indicate the whether there is a connection or supply between the controller from the Arduino to the controller. It's just an indication. Hope you are right. Hope are you clear, right? Okay, right. Okay, right. Let me explain the continuous. Okay, and then there are six switches here, right? These switches are for the movement of this. First two switches is for the movement of this first servo, next two for say, center servo, and last two for the gripper servo, right? These two switches is used to control this servo, and these two switches are connected in the pins 4 and 5, and next two in 6 and 7, and last two in 8 and 9. If you press this switch, the connecting rod, the motor which is connected to the connecting rod will rise, and the other switch then it will fall. And this switch, the offset of the gripper will rise and fall, and this will open and close of the gripper, right? Hope you all have understand. This each and every pin have been connected to the each and every switch have been connected to the Arduino pin. Okay, right. Now you have a doubt that before that you can also, there is another possibility that we can also use joystick model. Okay, why we have used here four buttons instead of that? What should be changed in the circuit if you are using the joystick model instead of these four switches? Before that, let us know what is the difference between the switch and joystick model. Joystick model uses analog values, where the switches gives the digital values. Before that, you have learned the about what is analog values, what is digital values in our in in our day one and day two sessions. But let us recall what are digital values and analog values. Digital values are analog values, which digital values are values which express only the values in binary format. It will be either in 0 or 1. It will be either 0 or 1. If it will be either in on condition or off condition. Okay, if the value is in 1, then the power supply is on. If the value is 0, then the supply is off. Simple. The switch is a best example of digital value, digital values. And analog values. Analog values are the values which will be varying with respect to time. Uh, for example, if you are using this, instead of using the switch, if you are using the joystick model, you can able to, as you have played the video games, you can able to, by the movement of the joystick, you can able to change the speed of the motor, right? Change the speed of the car, right? For example, in GTA, right? Like that, you can able to vary the speed of the motor by using the analog values. But in digital values, the motor runs only at the maximum speed of maximum speed. It will run
Watson, your voice is breaking again. Watson, your voice is breaking again.
now it is clearer, huh?
Yeah, now it's clear.
Ah,
Now
okay,
it's,
right. From which spot its voice is breaking?
yeah, just now, like immediately I
Just now.
said.
Okay, right. Okay,
Start,
okay, okay.
start from analog.
Okay, analog. Okay, analog signals are the signals which will produce the varying outputs depending upon the time. Okay, the analog values of servo motor will be ranging between 0 to 180, and then the analog values of DC motor will be ranging between 0 to 255. If the analog value of DC motor is 150 127.5, then the motor will run at medium speed. Depending upon the values which we give us input from the joystick, we can able to vary the inputs, right? Hope you all have understand. And then instead of having these four switches, we can also have the joystick module. Okay, hope all you have understand. Or if you have any queries, let me, I will explain again. Okay, okay, right, okay, right. Hope everyone is clear with the exact thing, exact that controller, right? Okay, right, okay. Before we are jump into code, let me show the model which have been done by us. Adya, can you show that model, right? Adya, can you hear me?
A video.
Yeah, da. Now you
It's
just
like,
go after.
okay, one second. I'll show you the video itself from my laptop.
Yeah, it's here, okay, right.
It's there. Yeah,
Okay, right.
yeah, show it. Play it now.
One
It'll
second.
be playing it now.
mm, one second. As you
Yeah.
can see, the exact model which we have been done using this.
I think the internet is slow. I'll stream it.
Okay.
Shall I?
Yeah, it's running, right. It's running.
It's running now. Okay.
Okay, right. I have a lag with my internet. Let
Okay,
me
then
stop
I'll
sharing. You'll just share the draw.
yeah, I'll stream it then. One second.
Okay, right. It's okay. Okay, you just stream it draw. I have a lag it.
Okay, one second. One second.
I'm
Yeah.
starting onwards. Yeah, we have used the buttons. Same thing. Same that thing. We have used the buttons for the operation.
So are you guys able to see my screen now?
Yada. You
So
just
here's the
fill
video.
that.
Wait a minute. I will show you the video like how it works.
Hey, from starting onwards, draw.
Starting only. Start
Okay,
onwards.
right.
It's moving.
Okay, right. Hope all you have
Hope you have
exact
seen
idea
this
what
one.
we
That
have
is the
made.
actual project we did. Me, Srivatsan, and other guys, Krishna Swami, we three were team, did that project.
Okay. Right. Do you have any queries? Just post it now. Before
So
we are going to jump into the code session.
if you have any queries, we'll be answering those. Else, we'll start with the code now.
Yeah. Okay. Right. Aita, you just share the code session, Ra.
Yeah, one second,
Let me
guys.
explain
Yeah,
the initial part.
yeah, yeah.
Oh, okay. Right. Okay. Now you can able to see the code thing, right?
Yeah.
Okay, right. One second. Now you can able to see the code thing, right? Okay. First of all, we are initializing the pins for that. What for that pin? What is the use of that pin? Using the constant function up into for the up pin for the servo, which is connected to the connecting rod. Down pin is for the up movement, the connecting rod for the up movement, and down pin for the lower movement of the servo, which is connected with the connecting rod. Tilt up, tilt down is the intermediate motor, which is connected in, right. Others, do you have any queries? Okay, right. Okay. Only servo motors. You can also use DC motors depending upon these
Application.
okay. One second. The servo motors is for only low torque purpose. But in industrial level manipulators, they are mostly servo motors for the demonstration purpose. We are using servo motors, but for the industrial purpose and the real time application, they are using the DC motors because there is a need of high torque motion for the manipulator. It need to bear the base motor need to bear the weight of the entire manipulator, entire gripper, the motor which is connected in between the gripper and the connecting rod, and also the manipulator and
Also,
the
sometimes
motor.
they also use stepper motors.
Yeah, stepper motors, which is also more efficient when it is compared to servo motor. Okay, okay, Adi, you just explain the remaining part of the code. Any other queries, guys? Before I am passing the remaining part of the code to Adi.
So looks like I don't have any doubts. If there are doubts, she can inform me since I'm presenting the screen right now.
No, okay. Let me explain. Okay, not a problem.
Okay then. Shall I go into the loop now? Yeah, okay. Then I'll jump into the loop. They meet right? Yeah, okay. So here, as Stevenson said, we have set up everything. Here is a servo dot attach. So attach is an inbuilt function to inform the Arduino that a server has been attached and deal with it properly. As simple as that. So for the there are four blocks for this code. The first block is the movement control. So as you saw, we have had four buttons: forward, backward, right, left. So what we're doing here is we are checking which button is connected, which button is pressed, and so that which direction we need the robot to move. So in here, first I have checked digital read. As you know, read reads what we need. So when reads the value in that pin. So digital read reads between 0 and 1 depending on the value. So when you give digital read to the forward pin and the button is already clicked, that pin alone will be high. So when that is high, we know it needs to go forward. So since they are given motor pin 1, 2, 3, 4, we can give 1 and 3 as high because 1 and 2 are for one motor, 3 and 4 are for the second motor. So 1 is forward for one motor and 3 is forward for the other motor. So 2 is forward backward for one motor and 4 is backward for the another motor. So depending on that and our application, we need to be coding this. So here we just need it to go forward. So motor pin 1 we have done high, motor 3 high, so it goes back forward. Now then, so you would be thinking, okay, we have given high for that. Why am I giving low for the others? So this is to make sure that when you are pressing forward, it goes forward, and sometimes it goes forward always, just to make sure of it. That's the reason we have used given also, make sure the backward pin is low, right pin is low, left pin is low. So here, after the second one is I given backward pin as high and the other pins as low, so that it can be sure, so that it can go backward. So motor 2 and 4 are given high, so that the motor rotates in a backward direction. So we're extremely sorry for extending this to 8:30. We just wanted to make
And
the concepts clear
and
and
also sorry
we
for
got
the
carried away.
glitches which have been, and also sorry for the glitches, network glitches. So sorry.
Yeah, guys. Will like these are personal issues we faced. We're extremely sorry. We'll make sure to correct it tomorrow. There is- if you guys any other have any doubts, please ask. Other than that, also once this is done, tomorrow we'll be going into computer vision, which is an exciting new topic, which you will be learning about computer vision, like uh, how a robot can perceive things. You won't be going too deep into it, but we'll be starting the basics of it, like what is a computer vision. We'll be using Python for it. There's an excellent team working on it. Tomorrow we'll be going through that. Power and 5 is going to be open CV. You can search about it, come if you're interested. It's completely Python. We'll be teaching you from basics too, so don't worry, it's easy. If you guys have any doubts, you can ask. If not, the session is done. Also, do follow us on our guys are in LinkedIn. We also have Robotics at Club at Sastra there. Follow us. Thank you, Professor. Okay, why is your name Professor? A fan of Money Heist, I guess. Am I right? Berlin. Okay, makes sense. Okay, guys, if you have any doubts, you can ask, or else you can start leaving. We'll be sending. Also, guys, we'll be sending you the feedback forms. Feedback forms are considered as the attendance today. So make sure you fill in the feedback forms for certificates. Where did I learn all this? Just I had the interest, went out there, tried some simple projects, burned a couple ICs. Then I got what it is. I have
And
burned
also
multiple.
get smashed in other university projects. And also get smashed in other university projects, university competitions.
Yeah, Jebin certificates will be online, will be soft copies. So also there are multiple competitions that will be happening around the world. Like for example, NIT Trichy has Pragyan, NIT like IIT Madras has Shastra. Yeah, Shastra. That's Shastra. I went there for just very about like looking. Aditya knows what my team did. So, Chandru, do I know you actually? I'm not sure. Okay, fourth floor. Fourth floor last year.
I think it's about hostel. I think.
Oh, promotions. Okay. Can you elaborate? I'm not sure. Also, by the way, who is this? Professor, for resources, you just search through Google. There will be multiple YouTube videos for. They'll be doing multiple projects. You just so look at these videos. You'll be inspired for yourself. Oh, you okay, okay, okay. I remember now. I remember. I remember. I remember. Okay, okay. Yeah, it does get confusing. Like I'm also planning to learn lot of stuff, but I don't know what to learn. It's really confusing for even for me. Like start from the basics. Learn what is Arduino Uno. When you're free, if you have money, try and buy an Arduino Uno and do it yourself always. So that's how you know when you. I'll be honest. From failure, as everyone says, from failures is when you learn. So when you burn a couple of Unos, you know how to use a Uno. Yeah. So that's how we learn. Like by the session is over, you guys need to leave, we can leave. When does the recruitments happen? The recruitment will be happening next year around the March time again, I think. Just like this time. This time around. By the way, guys, I'm robotics and AI department. If you guys have any queries regarding that, you can ask me. But sadly, I won't be able to answer all the questions because we are the first batch. Don't ask any questions about placements, please.
And our streaming is going on in YouTube. Yeah.
The stream is going on. Like, wait. Okay, we'll just tell him to close 1 second. So, for to be the part of the club, you don't need to learn too much, but uh, you should have the interest to learn. That's the main
Curiosity,
thing.